right, so for section 4.4, and this is the last section from chapter 4, so Monday will be a review day and Tuesday will be your test over chapter 4. Anyway, section 4.4, we're going to solve exponential and logarithmic equations. So for an exponential equation, it's going to be an equation containing a variable in the exponent. All exponential functions are 1-to-1. So no two order pairs have the same second component. Anyway, so if you're solving an exponential equation, your first thought is, can I make the bases match? Because if I can make the bases match, the exponents have to be equal. So that should make some sense. If these b values are the same, and I'm saying that these are equal, then those exponents have to be equal. So our steps in this, if you think you can make the bases match, then you're going to rewrite the equation where the bases match, set the exponents equal, and solve. Alright, so examples of that. Here we see that we can write 125 as 5 to the third. So now we have matching bases of 5. So I can just say that if those bases match, then those exponents have to equal. So when I solve this simple problem, add the 6, divide by the 3, and we're done. Alright, exponential functions have a domain of all real numbers, so you don't have to check your answers unless you're unsure of yourself. Alright, so here, I can write 4 and 8. 4 and 8, both as a base of 2. 8 is 2 to the third. 4 is 2 to the second. If there's already an exponent there, it just gets multiplied by the one you created. So I chose to make 8 2 to the third and 4 2 to the second. I just rewrote them so that the bases match. So now I can say that the exponents match. So we have this equal to this. Distribute. Get your variables on one side. Get your numbers on the other, and you're done. So we subtracted 2x from 3x, we subtracted 6 from negative 6, and we got that x is negative 12. And again, if you want to plug these in and make sure that they work, you're welcome to, but any number is fair game for the answer of an exponential, so you don't have to. Alright, unfortunately, we cannot always make the bases match. So, our way to solve in that case is to use natural logs or common logs. It doesn't matter which one. This book likes to use the natural log to solve your equation. So you're going to isolate the exponential expression, so get the exponential thing by itself, take the natural log of both sides, and then simplify from there and solve. So we'll work one. Alright, and you may have been shown a different way, because this is honestly not how I teach this in Algebra 2, but the way that I normally teach it and this way both work. Alright, so your exponential is by itself. So if we take the ln of both sides, and I think I'm going to show you both ways and you can pick which way you want. So I'll work this one this way and the other one the other way, and you can see. Alright, so the next step is this exponent can swing around out front. And then we divide that ln of 5 to get x by itself. And then that is something you can just type in your calculator. So in my calculator, if I do ln of 134 divided by ln of 5, I get 3.043. Right, I like 3 decimal places unless they tell you to round to something else. Just give me 3. Alright, so on B, you have options of how you can work it. Actually, we're just going to stick to their way. That way we don't confuse anybody. Alright, so we're going to do Since this is a base of 10, instead of doing ln, I think I am going to do log in this case, just because it works out nicer. So if I do log of 10 to the x equals log of 8,000, then log base 10 of 10 cancel, and I just have x equals log of 8,000. If you did log on this one instead of ln, it wouldn't have canceled, and you still would have followed the exact same process. So over here, I just chose log because it was a base of 10. It doesn't honestly matter. All right, so we do log of 8,000. You get 3.903. All right, so our next question. We have this. You have to get the exponential thing by itself. By the way, this is like a weird font, and this should look more like this. All right, so we're going to add 5. Because our job is to get this exponential thing by itself. So add 5, so let's make that 63. Then divide by 7, because again, we want just the exponential piece. Alright, so at this point, you're going to, according to their rules, take the ln of those sides, which is nice here because it's going to have a matching base. So we do ln of e to the 2x equals ln of 9. Then ln of b cancel, and you just have 2x equals ln of 9. Alright, so then you would divide by the 2. And what goes in your calculator is ln of 9 divided by 2. And again, make sure that you do ln of 9, close parentheses, divide by 2, so that you can get the correct answer, which is 1. It's 099. Okay, so if you would like on that first problem, you could have done log base 5 of those sides. So I will show you the other way that you can do this. On these, we picked either log or ln, like common log or natural log, because of the base. Well, you could do the same thing here. If you wanted to, you could have taken log base 5 of those sides. And then these would have canceled, but you would have to use the change of base formula here, which would give you the same thing to type in your calculator that you got this way. So it's, again, like pick your poison. It's whatever makes you happy. All right, so for log equations, they're going to contain a logarithm. So we can use the definition of logs to solve log equations. So basically that just means you can write it as an exponential. So if you only have one log in your problem, you can write it in exponential form and then solve that problem. With logs, you need to make sure that your answer works because logs have a restricted domain. So sometimes you'll get like extra solutions, extraneous solutions, ones that don't really work. Alright, so we only have a single log. So if we write this in exponential form, 2 to the third equals x minus 4. That's something that we know how to solve. 2 to the third is 8. Add the 4, so x is 12. Now when I say check your answer, I just mean like mentally make sure that you're not going to get a negative argument. Because remember we learned on in lesson 4.2 that for logarithms you have to have an argument that is positive. So this cannot be a negative number or a 0. Okay, so if we take this and we plug a 12 in for x, 12 minus 4 is a positive number. So we know that 12 is a good answer. Alright, so next one. We need the log by itself. So our first step is divide by this 4. So we have ln of 3x is equal to 2. Alright, now you're at the point where you need to write it in exponential form. Remember, ln is the same thing as log base e. So you're going to say e to the second is equal to 3x. Alright, to get x by itself, you divide by 3. So e to the second divided by 3 is equal to x. Alright, so now you can type that in your calculator. So the e button is the ln button. You just do second ln. So e squared, and then divide by 3. And you get that x is 2.463. Alright, so there's only one log. Make sure the log is by itself. Write it in exponential form. Follow what you got. Alright, if there's more than one log, then we're going to have to condense or no war, you're just going to condense. I'm trying to figure out what this point of this slide is. I really don't know what the point of that slide is, don't worry about it. Okay, so if you have more than one log, you have to condense first, and then it's the same thing we were doing. So we're going to take this side and condense it. So it'll be log of x times x minus 3 equals 1. So it'll be log of x squared minus 3x equals 1. Remember, if there's no base, it's understood to be a 10. So they write this in exponential form. It's 10 to the first equals x squared minus 3x. You have an x squared. You got a quadratic. The easiest way to solve those is to make them equal to 0 and factor. So subtract 10 over here. Factor this guy out. So x and x. 5 times 2 is 10. If it's negative 5, positive 2, that gives me a negative 10 when I multiply, and a negative 3 when I add. So I get solutions of 5 and negative 2. Alright, so if we plug in the 5, we have log of 5, which is fine. And we have log of 5 minus 3, so log of 2, which is also fine. So we know this one works. If we plug in the negative 2, we're taking log of negative 2. Cannot take log of a negative. This one is garbage. Alright, so if you have more than one log and condensing is not really an option, if you can at least get one log on each side, then you can say that the guts have to equal. So if we have a statement like this, log of a base is equal to log of the same base, then these things have to be the same, or that can't be a true statement, because log base b is an operation. If I do the same operation to these two numbers and get the same answer, then those have to be the same number. Alright, so you still may have to do some condensing, but you have to only have one log on each side. So this side only has one log, so bring him down. Over here we have two logs. They are being subtracted, so when we condense, we do that with division. Alright, so now if I'm taking ln of this and it equals ln of that, then those two things have to be the same. Alright, now you're basically solving a proportion. So you're like cross multiplying, or you can just say I need to multiply this over here, so that it's no longer in the denominator. So multiply this out. You get x squared minus 3x plus 1x, so minus 2x minus 3. Again, there's a quadratic going on, so everybody on the same side equal to 0, so that we can try to factor. So subtract 7, that makes this minus 9. And add the 23, that makes this plus 20. So I believe that we can do negative, negative with the 4 and the 5. So we get x is 4 and x is 5. Alright, so if we plug in the 4 minus 3 gives us ln of 1, that's good. And 4 times 7 is 28, minus 23 is a positive number, and 4 plus 1 is 5, which is positive. So 4 works. right, what about the 5? 5 minus 3 is positive, 7 times 5 minus 23 is positive, and 5 plus 1 is positive. So this one works. All right. If you have questions, please let me know. The ones on the test are going to be pretty similar to the ones that were in the notes today. The ones on your homework might get a little more complicated, so if you run into trouble, send me an email and I'll be happy to help